What I'm here to talk about is 96 boards, but to talk about 96 boards, I need to give you a little background. How many folks in this room know what Linaro is and what they do? Okay, about half the room. I'm going to try to go through a little quickly on what Linaro is and then why we created the 96 board standard. And then we'll talk about some other stuff, including how you can get access if you want to test end-to-end IoT into the cloud, how you can get access to ARM servers for free for doing some testing. So with that, let's get this thing rolling. So who is Linaro? It's a collaborative engineering organization targeting ARM. Our mission is to lead the collaboration in the ARM ecosystem. Why do we need Linaro? It's pretty simple. Intel outspends ARM by a significant amount. ARM doesn't actually make chips, they make IP, and then other vendors make chips, Qualcomm, TI, and others in the world make the chips. And for a long time, those of you that have been in the embedded space know it probably more than most. For a long time, there was very little upstreaming of code going into the mainline kernel from the ARM vendors, which caused fun times. So ARM, realizing they had a problem, figured out that we needed a collaborative area where people could work from different companies together legally to improve ARM Linux. And they came up with the idea of a Linaro. And so here we are. We focus on the software. We've got over 220 engineers working on the software. It's built and shared by all. We don't charge for the software. We don't have a product that we're selling. 96 boards is not a product that we sell as we go through that. There are a lot of companies and people involved. Just some quick overview. The slides are online, so help yourself to look at these in a little more detail. I'm going to try to go a little quickly here. We do end-to-end solutions. So we've got anywhere from IoT, phone, home, LNG, and leg. All are different subgroups within Linaro working on specific areas. The light group is a new one. We're still in the development area of that. So, but the LMG has been around, LHG, the networking group has been around quite a while, and of course leg, the enterprise group, has been around for quite a while now. In fact, there's ARM servers out, and we'll talk about that towards the end. So we've got a new segment group that's coming on, specifically focused on improving things within the ARM group for this. As I mentioned, there's the LMG folks. We have continued focus, and the features migrate to IoT into the enterprise out of this group. The digital home, we've got Android, Comcast, China. It's focused on security and media frameworks for playing back video and other features. The LNG networking, we work closely with the standards to accelerate networking, and there's lots of things happening there. Again, I'm not really here to specifically talk about it, I just want to give you an overview. And then the enterprise folks, we've actually got ARM servers in the data centers, and this is coming along in a big way in standardization, which is important. So what do we need as Linaro to accomplish our mission? Well, the first thing we need are engineers to develop and work on and debug software, and we have quite a few of those. What's the second thing that we've needed and we've been fighting for more than 5 years to get? And that's hardware to actually debug this stuff on. We need standard hardware that we can get the source code upstream and that it'll be around for a while so that on a predictable life cycle so that we can work on it and use it to do our stuff. So we didn't design the 96 board standard because we wanted to be a hardware company. We designed the 96 board standard because we couldn't get hardware to use to do our job. So this was a way to get low-cost boards that we could afford to put a board on each developer's desk. And that was really the target for where we were starting. So 96 boards. Currently there's 2 specifications, and there's more specifications in development now and extensions to some specs. There's the consumer edition specification, and if you come up to the Linaro booth outside, we've got a bunch of the consumer edition boards from different vendors. So what is that edition? That says what the board size is, where the connectors are, how it mounts, Electrically, it says exactly what's on what pin. There are 4 vendors right now building boards. There are more in the pipeline. So it's pretty exciting. There's quad-core, there's octa-core, there'll be other boards, there'll be 32-bit boards in the future. So, but they'll all have the same, fit the same standard. They'll all have plug compatibility. So we've also got this idea of mezzanine boards. You've seen, we have a selection of those out on the table that you can see, and there's more of those coming. And those mezzanine boards all work within the family. So you can plug them on any one of the boards, and they'll just work. We've also done some library work that I'll talk about. If you write your code to the libraries, the binaries from a 64-bit quad-core, you can take that same binary, throw it on an 8-core octa-core, plug the board in, and it'll just work there too without a recompile. So we're trying to make it as standard and seamless as possible, primarily to meet our own goal, which is to improve ARM Linux. It just happens to meet other goals too. We've got the Enterprise Edition, which is a bigger board, a little more expensive. So the CE Edition is $150 and less. And the boards that we're showing out on the table are in the $75 to $80 range right now. The EE Edition, the Enterprise Edition, that's more of a desktop server board, so people that are working on servers can have something on their desk to work on. That board is sub $300 target range. And that has quite a few additional features I'm not going to go into right here, but if you're interested, you can go to 96boards.org and look at the specs, but it's quite interesting, and it fits a bigger board format. And then they're working on a new specification of Internet of Things, which is going to be a very small type board, powered differently, and it's really targeted at the Internet of Things and small devices. Why 96 boards? It's an open, low-cost platform specification. We maintain software that works on the boards. We share that. It's open to all developers. It's not just Linaro. The code is shared out. It's open for everybody. Our target is to get it upstream in the mainline kernel and in the mainline distros. If we have to patch something, we make it available. Debian, we're running a Debian version, and Red Hat's doing some stuff on the enterprise side. It's all trying to push it upstream. We don't want to maintain it internally. That's crazy. We're not a distribution. And as I said, the hardware modules are portable across all 96 boards. On the low speed, there's 2 connectors on the CE spec, a high speed and low speed. On the low speed connector, that's also on the EE boards. So if you build a low speed adapter, it'll go across the entire family and just work if you need it to. Why does it matter? Well, it's a SOC independent open platform. So because it's SOC independent, the standard will be around for a long time, and there will be boards around from different vendors. And it gives you some advantages. I know personally I've done development work where I've been working on a board, and I get 2/3 of the way or 3/4 of the way through doing my development, and the manufacturer obsoleted the board. Uh-oh, back to the drawing board. I don't know about you guys. How many in this room have had that happen to them in one way or another, boards getting obsoleted? Yeah, it's a pain point. Well, with the 96 boards, if the board you're working on should get obsoleted for some reason, and that's going to be less probable to happen because many of the SOC vendors are actually guaranteeing that their SOC is going to be available for 10 years or more, which is quite unheard of in this industry. But if it happened, all the work you've done would still be compatible with another 96 board, and you could just go find the next best board, pop it on there, and get going. Maybe you've developed your thing and discovered, I was using a quad core, but I need an 8 core, I need more horsepower. You can just go find one of the other 96 boards that has more power, put your code on it. If you've built a mezzanine board, plug it in, and it'll just work, and you'll be able to get moving. So that's really what it's all about. It becomes a standard that we can all work from with different SOCs. It's not just one vendor, it's not one SOC, it's across the industry. We're even doing a reference software platform. Linaro is not about hardware. We got this, we kind of put this standard together because we needed good hardware to do our job, which was develop better ARM software. So we're really not about hardware. It's really not about the hardware for us. But we are working on a reference build that works across all these platforms and works across other platforms beyond even 96 boards. And they just recently released one release. It comes out quarterly. And the idea, again, is to push all this goodness upstream, but it's a unified kernel. So our reference software build for 96 boards boots the 96 board family off the same kernel. So it's really changing the way ARM software is done. As I talked about the mezzanines, they're completely compatible across all the 96 boards. So if you build one, it'll stay compatible. If you use any one of 3 libraries that we recommend, your access to GPIO, I2C, and SPI, you'll have binary compatibility across the boards. So you may want to recompile for different optimizations if the CPU has more capabilities or what have you, but you don't have to. The libraries, for a very simplistic library, is 96 boards GPIO. It uses like digital read, digital write, so it's like Arduino kind of stuff. It's not very sophisticated, but if you just want to light some LEDs or read something quick, it works. libsoc is another library. It's written in C, and we're supporting that and adding extensions to it so that it runs across the 96 board family without having to be modified. And then there's the Intel MRAA and the UPM libraries, which again have had some extensions to add for 96 boards. That's a C++ library. So the 96 boards GPIO and libsoc are based on C. They've got Python wrappers, and we'll soon have some other wrappers for other popular languages. MRAA also has some wrappers as well. Just depends whether you want to use C or C++. We're going to support them all because the reality is, want your job to be better, find the right library for what you're doing. That's not my job to tell you. My job is to make your job easier. Target market. You got the pro and the hobbyist. You've got commercial and higher education. You've got makers doing robotics, all kinds of stuff. So turns out there's lots of people that want to use the 96 boards and are buying them. Again, we built them for a specific reason, to improve ARM Linux. Other people are using them for all kinds of stuff. To us, it's a key enabler for the reference software platform and the mezzanine ecosystem. Again, I talked about the standards, low cost from 50 to 150 for the consumer and under 300 for the enterprise. And you can go to the 96 boards site and look at the differences and figure out what boards might do what you need. Again, it's a low-cost platform. It's really designed for your use. And it's got a small fixed footprint, which is kind of cool. Out of the box, it's a single board computer. We're running some display software on it. It's expandable, and it's a low-cost board. Dragon board you've seen. Here's an interesting use. The high key is now referenced by the Google AOSP. So now there's a board associated with that can be tested on. That took quite a lot of work, but it's really an interesting situation. So again, people are adopting 96 boards for their use, what they need. It's not just Linaro. Here's a picture of 96 board enterprise. It's a little bit bigger. This is the LeMaker Cello. It's coming out. It's a quad A57 with Ethernet on board, SATA, PCIe, and so forth. So this is a bigger board, costs a little bit more money. You can put your own RAM in this, so you can put in as much RAM as you might need. It's not limited to 1 or 2 gigs. You can put 16 gigs or what have you. So it's really designed to be a different kind of a board, so it costs a little bit more money. It really is a pretty powerful board. It's designed, as I said, really targeting the enterprise market so you can do your development work before you can, a lot cheaper to put on your desk than trying to put a serious 19-inch rack-mounted server. Besides, you really don't want that rack-mounted server in your house unless you like the sound of fans. I'm not so thrilled about them. As I mentioned, there's lots of mezzanine boards. There's 3 of them here that I'm picturing. You've got the Linker Sprite board. You've got the UART board designed by one of our very own Linaro folks. It just brings out the UART so you can do low-level boot testing and early kernel work. And then we've got the mezzanine board over here, which brings out a lot of the GPIO It does level shifting because all these boards are designed around the 1.8 volt standard. And if you need it 3 volts or 5 volts, some of these mezzanine board products are specifically designed to do level shifting up to 3 or 5 volts. There's actually, if you're interested in robotics, there's a robotics board I just saw for the first time. I will be owning some of those very soon. So in terms of OS distributions, we're really OS agnostic. Linaro is not a distribution, don't want to be a distribution. All we want to do is improve the operating systems and the kernel. So we're completely agnostic, and we welcome all community participation from all aspects. Each product supports at least one of the distros when it first comes out, whether it's Debian, Ubuntu, Fedora, the Android AOSP, Red Hat, or Yocto. And in most cases, most of the boards support more than one. And as we get further, more and more upstream, more and more of the different distros will be supported. But again, we're trying to make it easy for them. We're not trying to be a distro. We have no intention of being a distro. It's not our job, not what we do. The supported distros do have pre-built images on the 96boards.org site. So you can download a pre-built image and test the board, make sure it's doing what you want, or you can build your own, whatever you want to do. Now, if you do pull down a pre-built image, the libraries that we're recommending will be pre-installed on those images. Although you can go to GitHub, and we're going to get them packaged, so you'll be able to get them in the popular distros as a package. All that's being worked on now. It's going to take a little time. I mean, some of this stuff takes months to happen, so it's not all here today, but it's all coming along. The libraries are all on GitHub today, so it's all there. 96boards.org is really the site. It's not Linaro. For if you're looking for information on the 96 boards and you're interested, 96boards.org is the place to go. The latest information will be loaded there. And that's the specifications down to the spec on some of the chips, the reference software, and there'll be information about Developer Cloud, which I'll be talking about in just a few minutes. Any questions so far? This will be real short, quick display if no one has any questions. Yes, sir. The license on the libraries are all open source licenses. libsock is ldquo, I believe. MRAA, I forget what that one is, but it's definitely an open source license standard. It's not restrictive. Yeah, and the 96 boards GPIO, the simplistic library is built on top of libsock, so it runs the same license, but it's a very open source license. I think it's LGPL, but off the top of my head, I just don't remember, sorry. Okay, reference platform, change the topic just a little bit. We've been working on an end-to-end reference platform. It's open source. It really is a how-to on how to do this stuff with ARM and get it upstream. Over time, we'll get more and more boards booting off the same kernel, and we get the ARM kernel in the same place where the x86 kernel is, so we don't have to have different kernels for each board. It's really kind of a mess, but it's getting better. Linaro has been doing a pretty good job. This is a place where we can work on that. By doing this, it saves a lot of duplicated engineering effort, and that's really what we're targeting to do. We want to get this thing in really good shape and share it all together. So the reference platform is tested on all the 96 boards and on different member hardware who are participating in the Linaro experience. It includes the latest distributions, and it's targeting IoT and digital home and several other things. It will have a quarterly release cadence, and I've put the GitHub URL here. This morning I sent in the slides, so all the slides should be uploaded, and you can grab it, and there's as I close this out, there's a reference page with all the different URLs, so just grab that if you don't have to scribble real quick trying to write this down. This is just a little more information. It's a unified kernel tree for the CE and EE builds right now. It's supporting a lot of boards, as you can see, and it's Linux 4.40 based. We're really trying to stay at tip with this and trying to push the changes upstream. Again, our focus is to get as much upstream as fast as we can. Now, I said that's our focus. I'm not saying that we're always successful. It's not an easy job always getting all the stuff upstream. You have to work with the vendors and show them where maybe what they're doing isn't the right way to do it to get it upstream. So I'm not saying we're perfect. I'm not saying we win all the time and it instantly goes upstream. I'm saying it is a focus and we continuously work on this to move more and more upstream. So, if you look at something and it's not there today and it takes us 6 months to do, that's possible. It may take longer depending on what it is, the feature, and how we go about it. But the goal of Linaro is to move this stuff upstream where it belongs. Oh, boy. And it is a job. So I was mentioned at the beginning also on, we have a server cluster. There's actually real ARM server hardware these days. We have a cluster of it in Austin, Texas, in a colo. And any ARM developer can gain access to that for free if they want to do some testing. And there's a URL here where you can go and request it. You say what you want to test and how you want to do it, and you can get access to real hardware. Now you can take that and tie that in with 96 boards. You may have an IoT application and you want to do end-to-end testing. You have the access to real servers. You can buy a 96 board at a reasonable price. You can add some IoT things, and you test the entire thing end-to-end for free. That's pretty exciting stuff. And again, these are real servers running real OSs like Red Hat, CentOS, and other things. And you can request which one you want to boot, and it'll be there, and it's completely private. So once we hand the machine over to you, we tell you how long it's yours. It could be a week, it could be a month, depending on what you're doing. Once we hand it over to you, we can no longer access it. The only thing I can do is destroy the image and start again. So you can load anything you want on there, and when we're done, we just tear it up and completely reformat everything and re-image the machine. So this is available to ARM developers. So it's quite a few people have used it. I suspect more will over the coming year. And now we have a new thing coming. It's called the Linaro Developer Cloud, and it's taking it to the next step. So the ARM, this slide here is talking about actual hardware. So if you want to, for some reason, test on specific hardware, you can. But here we're doing an OpenStack cloud with a full open implementation. It gives you complete access to public and restricted hardware. And it lets you, for cloud providers, they can experiment from a known starting point on ARM servers. This cloud has just been announced at the last Linaro Connect a month ago. And it's going to be available. It's currently running in Austin and running in Cambridge, and shortly to be running in several other countries. And we'll be able to provide a unified infrastructure. We expect China next, and we'll be able to federate these clouds all into one giant federated cloud across the world. And again, this is something that different developers can request access to and gain access to at no cost, or for specific things there may be a cost of depending on how large of the cloud you need. Again, we'll be doing on this a quarterly release cadence, and it's out there. So it's really a way to go from IoT, 96 boards, and test it all the way through to the final end of the cloud if you want to, and make it available to you. Linaro is out here to improve ARM Linux and make it easier for you to gain access to while things are still a little hard to get your hands on. Although today, a year ago when I started the hardware cloud, it was almost impossible for anybody to get access to an ARM server. Today you can actually buy a few of them. They're actually becoming available. But in the meantime, there's still not enough of them out there, so we'll help you with that if you want. It's your call. So, getting close to the end of this thing, I'm kind of going fast. Sorry about that, but we need your help. Linaro has 200 and some odd engineers, but we need the help of the community. And how can you do that? Well, buy a board and contribute on 96boards.org forums. The boards are under $100, so they're pretty cheap, and we really encourage people to do that. If you're a company, you can join the 96 Boards group, and it's for SOC vendors and board developers and so forth, and we can help you and steer you and help make sure that the boards are certified and other pieces. We have different partner programs for this on the 96 board and the mezzanine side, so there's a lot of opportunity here. Please come and play, come and join, and help us build this thing out and help make ARM Linux better. Here's a bunch of resources for people who are curious about Linaro, the server cluster, 96boards.org, the different libraries, kind of put references to all that stuff. It's all available. And as I say, it's in the slide deck has been uploaded, so you can just download it if you want to. So questions? Any more questions?
I'll just speak up. I looked up the license, MIT license. MIT, oh, right.
Thank you, Grant. Appreciate that. So, yes?
What other SOCs are you looking at? Do you have any on the roadmap, or is that just kind of?
Well, right now we've got the Qualcomm SoC, we've got the HiSilicon SoC. Who's the bubblegum SoC? I forgot. Action Semi. Marvell has got one that's going on that's been announced. And the ones that haven't been announced, I can't talk about yet. I can't even really give you a hint, but I know of at least 4 to 6 more boards in the pipeline from very early stages to actually quite near releasing. Some of them may well be duplicates of the vendor already doing it with different chips, and some are definitely additional new vendors. So there's going to be really a wide range of vendors, of SOC vendors that are supporting this standard. So again, this is not us producing hardware. Linaro's not going to go building hardware. Well, we have a few of us that are a little geeky and build a few odds and ends like the mezzanine boards, but our goal is not to build the 96 board. We produce the spec, we work with the vendors to make sure they adhere to the spec, we modify the spec where necessary as we discover new things that need to be added, but we're not trying to build hardware. If we could avoid it, we would have not even done the 96 board spec. The whole reason we had to do this is we couldn't do our job. We couldn't get boards that we could work on that the code was upstream or upstreamable and that lasted long enough to be usable for us. You'd buy a board, and a year or 2 years later, the board would be gone, and we're scrambling for, now how do we continue this work? With the 96 boards, we've got a solid set of boards that we can work on, continuing to improve ARM Linux. So that really is why, that's the driving force. People have bugged me a lot of times, why are you doing it? I don't want to do hardware. I like to play with hardware. I love to build things in my own house. I built my own sprinkler system now it's using a 96 board. But I didn't go out and say we should build a 96 board spec so I could build a sprinkler system. It was more like, oh, cool, a new toy I can play with. But the reason is to do our job to improve ARM Linux, we've got to have reliable hardware. And it just turns out once you've got reliable hardware, lots of people jump on it and start using it for other things. Any other questions? Yeah. What are the top 2 challenges? Well, the first one is working with the various vendors to learn how to do upstreaming. A lot of them have not had the experience in order to know exactly how do you upstream, how do you work with the kernel group, how do you get the right bits at the right time so people will add that in and start looking at it. Because too many vendors will work on something, throw it over the wall at the end of a kernel cycle, not at the beginning. Right? So that's really one of the biggest, hardest challenges, I would say, is educating people how to work upstream and moving these things. I'm going to cheat, and I'm going to put somebody else on the spot because I'm looking at him. Grant, what would you say is another really hard challenge?
Okay, so I would say that the other challenge is the ecosystem. of making Linux on ARM a real thing. And what I mean by that is that there's a lot of bits and pieces that need to work together for a fully functioning system. On your phone, right now, the way that works is the phone vendor takes all the pieces. I mean, they start with Android, but there's a whole bunch of integration bits and pieces that go together. A lot of that engineering work really doesn't need to be done every single time. In fact, I think that we've got a security nightmare because our industry works that way right now. And it's no different for IoT. The fact that we've got these vertically integrated stacks that have to be, the company needs to do that engineering, I see that as a problem. So the challenge is, which 96Boards is actually part of our solution to, the challenge is to find the bits of the stack that are needlessly different.
And get them standardized.
And get them standardized. So one of the things that's my big thing right now is I'm pushing really hard to have UEFI on as many boards as possible. Not everyone's happy with UEFI. There's a lot of kind of mixed feelings on that. But one of the things that UEFI has done incredibly well is specifying the boot flow. So it's consistent between platforms. And therefore, and we've got within that a security model. And we've got a way that distributions can support it. So when I look at a platform that's UEFI standards compliant, if we've got a bunch of boards on that, we can have a single Linux distribution that will run on all of them without having to do magic stuff.
And we really want to avoid the magic stuff. That's where you get into the security holes, because somebody will invent the new security platform, the new model. Yeah, okay, we haven't learned from all the other ones.
So I'm going to add to that, though. But this isn't so much the challenge, but this is the added advantage. And I'm going to call this the European Union discussion. We have to participate. So in the trying to get things standardized, like going back to the UEFI example, by working towards that, getting all of that stuff running, it also means that we're participating, and it means that we're at the table, and that we can influence and affect the relevant standards so that we can get our goals met.
Yeah, I mean, coming back, looking at UEFI, the original UEFI spec had no idea of ARM. So we had to get things added to the spec to support ARM. If we're at the table and these discussions in the future, we don't have to try to get it added later. It all comes together in the beginning. So these are all challenges. There's no real simple answer, but the one answer is participate with Linaro, help us drive this thing forward. If you need hardware, look at 96Boards. I think it will serve your needs quite well. And if it doesn't, participate in the standards process of the specifications and get it added to a spec or maybe create a new spec. They needed an IoT spec, it's being worked on. Other people needed to modify the spec. The EU spec is being slightly modified for another purpose because it meets pretty close to what the home group needs. So they're adding some extensions to it. So here's where you participate in that. If there's something missing, bring it up. This is a community thing. Let's get this thing to be extended, expanded, and supported. We can't do it ourselves. We started it, but people have taken the ball and run with it. I mean, they've sold thousands of these boards already. They're not just going off in the closet somewhere. People are building stuff. They're building robots. They're building all kinds of craziness. I put my own sprinkler system together. No, I'm not going to sell that commercially. I needed it for a different reason. Texas had a severe drought, and there was really big fines if you watered it on the wrong day. If you ever want to have a conversation about weird things about watering, I'm happy to do it. But every commercial watering system less than $1,000 wants to water on a weekly schedule, not anything else. Enough said about that, unless you want to talk later outside. Any other questions, please? Yes, sir.
What would you say would be the major incentives for a vendor to work with 96Boards?
Okay, why is it attractive for a vendor to participate in the 96Boards program? So one of the things that's very attractive is cost. When you're trying to design a board, it can be very expensive to spin a board. On the 96Boards program, certain parts of that spin are already relegated and designed. You're going to drop your sock in, there's going to be some work that you have to do, but some of it's already designed, it's laid out where it's going to go, you know where the connectors are, you know where the I/O is going to be, and that saves money. The other reasons why it's a good thing is, again, because people are adopting it, and now there's mezzanine boards. You can build your 96 board with a brand new sock, and everything that exists in the mezzanine or field will run on your board. So you've suddenly got a built-in bunch of I/O that you didn't have when you built your own board. I mean, if you take a look at some of the other boards that are on the market, there's lots of boards that are not 96 board compliant. Some of them have managed to attract a big following, but they're basically single vendor sock boards. And if the vendor decides to change what they're doing, and some of them have, all of a sudden, I/O that's built is no longer going to work on this board, and they've obsoleted that board. With 96 boards, if you're building your board to that standard, all the mezzanine products are going to work. The libraries are going to support it, because we're going to, as we extend and add new socks, one of my team's jobs is to extend those libraries to support those, so that across the board, if you're using the libraries, you don't have to worry about how to enable the GPIO. You won't have to worry about how to enable I²C. Just use the bloody call, and it'll just work magically. It's a thin shim layer. Yes, you could do without it. You don't need it. You could go do it, and then you recompile it and change the numbers for a new sock. It's not a huge deal, but it's a way to get it completely standard across the board. So that's really a reason. Grant, you look like you have one more reason or something.
I'm going to publicly disagree with you a lot on one.
Okay.
The recompiling to change, GPIO numbers, I see as a huge deal. And that's one of those little paper cut barriers that causes a lot of problems. So I think the fact that we are looking at, okay, how do we get the shim layer in, is far more significant than it looks at first blush.
I'll agree with that. I mean, since I was the one that fought for it and everybody told me I was nuts, I'll agree with you. But yeah, I mean, it's a big deal. If you're a developer, do you want to have to go learn how to use 4 or 5 or 10 different socks? Or do you want to use one library and it just works? It's your call. I mean, we all can learn it. It's not hard. You go look up the data spec and go, there's the number.
I'll add a little bit more to that, because we keep talking about 96 boards and standardizing on that. Our hope is that while we're looking at the 96 boards ecosystem, there's an awful lot of flow through that affects the rest of the ARM ecosystem, actually the rest of the Linux ecosystem. So there are things that I've discovered working with the High-Key and the Dragon board, trying to get software running on both. That highlights some things, that shows where we need libraries, that shows where we need infrastructure. Building out that infrastructure is equally advantageous to the Raspberry Pi ecosystem, or the BeagleBoat ecosystem, or even the Intel Galileo ecosystem. And for us as Linux developers trying to build Linux products, I think that this is incredibly valuable.
And actually, to mention that, we're talking about the libraries for 96 boards. While we were cleaning up libsock, we added BeagleBone Black support. So it's not just 96 boards, but we are doing other things as well. The idea is get it down to where it's easy to use. Get it down where it's not magic. This should not be hard. Yet today, depending on the board, it really is hard. More questions? Okay, well, then I will thank you for your time. Feel free, there are some other presentations here at the ELC. Bernard is giving one tomorrow. Cohen, it's here, look on the thing, but everybody's from Linaro. I think everybody's putting out some really good information. Please attend their presentations. And thank you for your time. Bye now.